So let's continue with the factoring method. We're still in division of polynomial, but still in factoring method, or using the idea of factoring method or division by factoring method. And we have just done with the uh, division of algebraic expression of binomials, trinomials, and multinomials, where the divisor is monomial. So this time, we will try to divide algebraic expressions where the divisor could be binomial, trinomial, or multinomial if possible. Okay, we're still in factoring method. Okay, for example, you have here x squared minus 1 divided by, okay, so divided by x plus 1, for example. So again, to recall, um, previous weeks, I uploaded the discussions or review discussions about the factoring. And I hope you studied the uploads and you can still recall how to factor algebraic expressions. Okay, for this one, since you cannot break this, you cannot simplify this, you cannot divide these expressions by breaking into two fractions. The idea is you need to factor out either numerator or denominator, or maybe you can factor both numerator and denominator. Okay, so again, if the divisor is already binomial or trinomial or multinomial, by using the idea of factoring, either you factor out the numerator or factor the denominator or factor both the numerator and denominator. So these are the three possible ways to divide algebraic expression when the divisor is binomial or more than one term and using the factoring method. So since x plus 1 cannot be factored, try to work on the numerator. So if you can still recall, x squared minus 1, the first term is perfect square and the second term is perfect square, and the operation is minus. So therefore, we can consider that x squared minus 1 is a binomial, which is considered the difference of two squares. And if you can still recall, the factor of difference of two squares is just copy x and then operation and then 1, the second term, and then okay, as the first factor. And then for the second factor, just copy again the first and the last, which is 1, and then take the opposite of the original operation from minus, that becomes plus here. So that's how you factor if the given expression is difference of two squares. And then copy x plus 1. And then try to see the common expression of numerator and denominator, and that will be the time that you need to perform the division by cancellation method. So that means the answer is x minus 1. So as simple as that if you have mastered the factoring algebraic expression. So that means x squared minus 1 divided by x plus 1, the answer is x minus 1 by using factoring method. So for this part, you need the mastery of factoring algebraic expressions. Let's proceed for number 2, for example. Supposedly you have x minus 2. Okay, x minus 2, and the divisor is x squared minus 4, for example. By factoring, numerator is not factorable anymore, so just copy that one. And by examining the denominator, the first term is perfect square and the second term is perfect square, and the operation is minus between the two terms. So that means that the given expression is difference of two squares. So you can apply the idea on how to factor difference of two squares. So simply just copy the variable and then or simply distribute the variable for the two binomials and then get the factors of 4 that is because the factor of difference of two squares, the first term and the second term, the factors of the first terms are the same and the factors of the last terms are also the same. So the factors of 4 that will give you the same expression value or number, that is 2 and 2. And then copy the operation here, and for the second operation, take the opposite of minus, that is plus. So therefore, when you factor out x squared minus 4, the resulting factors are x minus 2 and x plus 2. And then after that, you cancel the common factor or the common expression of numerator and denominator. So by cancelling x minus 2 here, so the remaining value for the numerator is automatic equal to 1, and then copy x plus 2. So as simple, as easy, as faster as that, if you have mastered the factoring and algebraic expressions. Again, I keep on repeating this one. So x minus 2 divided by x squared minus 4, the answer is 1 over x plus 2 using factoring method. And for the third example, perhaps we will have this one. X squared minus 3x, for example, and plus 2. And then you will have here x squared and you have minus 4. Okay, x squared minus 4. This time, for number 2 and number 3, okay, they have the same divisors, but they differ in the numerator as to the. So, to continue with this one, because we're still applying the factoring method, so try to factor out the expression first in numerator. So this is trinomial. Typically, if this is factorable, the factors are the product of two binomials. So again, the technique is just here. So just distribute x, and then can you still recall that if the middle term is minus and the last term is plus, all factors, okay, have minus as operations between the first and second term of your factors. And try to factor out 2. Okay, the factor of 2, that will give you the sum of 3, that is 2 times 1, because when you add 2 plus 1, that is equal to 3. So that means, since they have the same operations or signs, so you can just either place 2 here, and this one is 1, or maybe you can place here 1 and 2. You can interchange the numbers since their signs or operations are the same. And then, it is already given that this one is this x squared minus 4 is difference of two squares, so the factors are x minus 2 and x plus 2. And then look for the common. So the common expressions here, the common factor here is x minus 2. Just cancel that one out. So the remaining expression in numerator is x minus 1 and over x plus 2. Either you place them inside the parentheses or not, that is still acceptable. So x squared minus 3x plus 2 over x squared, or divided by x squared minus 4, the answer is x plus 1 over x plus 2. As simple as that if you have mastered the factoring expression. The last one for this one is when you have x squared, okay, plus 4x, for example, and then minus 5. Okay, so 4x x squared plus 4x, okay, minus 5. And you will have x squared, mm, so let's say minus 2x plus 1, for example. So the dividend is trinomial and the divisor is trinomial, or numerator is trinomial and the denominator is trinomial. So just simply try to factor it first. So for this expression, basically again, if the given is trinomial, given that it is factorable, so your factors are product of two binomials. So just distribute the x here, and then try to factor out minus 5, that will give you 4 as their sum. So for 5, minus 5, negative 5, so it could be negative 5 times 1, or it could be negative 5 times negative 1. And try to add these two numbers, which one will give you a plus 4 or positive 4. So when you add this one, negative 5 plus 1, that is equal to negative 4. But the middle term here is plus. So when you add 4 plus negative 1, that will give you a difference of positive 4. So that means 5 and negative 1 are the factors that we need here. So for positive 5, automatic, that is plus. For negative 1, automatic, that is minus 1. So that is the factor, or that's the factors of x squared plus 4x minus 5. So that means if this one, okay, when we factor x squared plus 4x minus 5, the factors are x plus 5 and x minus 1. And proceed to the denominators. The same, that you need to distribute x here. And then, again, if the middle term is minus and the last term is plus, so that means all factors, okay, will be minus in the second term. Okay, between the first term and second term. And the only factor of 1 that will give you, the only factors of 1 that will give you 2 as their sum is 1 times 1, because when you add 1 plus 1, that is 2 also. That is automatic 1 here. And then after factoring, look for the common. So obviously, x minus 1 is common for numerator and denominator. So dividing by cancellation, and the remaining expression will be x plus 5 over x minus 1. So this is your quotient. When x squared plus 4x minus 5 over x squared minus 2x plus 1, okay, when we divide these two expressions, the result is x plus 5 over x minus 1. So I guess it is only after that for the division of algebraic expressions using a factoring method. And try to practice this for you to check yourselves if you are able to understand the review discussions. Okay. If it is possible, if um, all expressions here can be factored, so try to perform the division. And for number 1, that is x plus 3 divided by x squared plus 5x minus 6. For number 2, you have 6x squared plus 12x divided by x squared plus 4x plus 4. For number 3, you have x squared minus 7x plus 10 divided by x squared minus 25. And please practice and try to study and study so that when we come back to our regular meetings, you will not give me 0 as your score. Thank you and good afternoon.